Hello all, today we have Mr. Ashish Udani, a Senior Application Engineer at Midwest Engineering Systems, to talk about career paths in robotics and automation. Some of Mr. Udani's career highlights include 30 plus years in engineering companies such as ABB, Rockwell Automation, Eaton, and many others. Thank you so much, Mr. Udani, for your time here with us and all the other teams that will be watching this video later. Thank you, and you can start your presentation.
Thank you. And I'm sorry?
Avanish.
Avanish, that's right. Thank you, Avanish. Yes. So, well, I'm really tickled to be here. I tell you, I mean, I'll try not to go on my history here for too long because I don't want to take up your recording time, but I had a 2017 graduate come through BC here, and I have one coming out hopefully by next June. So, yeah, he better take his civics exam. That's all I can keep reminding him about that. It's probably going to forget too. So anyway, I'm really happy to be here, and the idea here today, I just wanted to, the thrust of what I'm going to kind of talk about. I have a presentation prepared, but sometimes I go off the cuff, okay? And that's partially probably because of my recent last few years in sales functions. So you tend to talk a lot. So if I do too much, stop me, ask questions along the way. This is, you know, I'm not part of the Matilda crew where I'm performing here. So, you know, that's next week. Really, my thrust here today is to let you know, and the way I titled it, it was not the most creative title. And I know, Deborah, you asked for something. I'm sorry, this is the best I could do. But for all is the real critical thing. And robotics and automation career for all, because I think historically, even me, from a perception standpoint, you know, people think that, oh wow, you want to do robotics, you're going to have to, you know, take Calc 3, AP, you know, exam, you know, physics 1 and 2 or C or whatever, you know, it's called nowadays, and you have to really, you know, take really high-level advanced classes to do that. There is a path to that, and we'll talk about that. But to get into this field of work, I don't want people to be intimidated by that factor. It is a path, but there is another path as well. And that's why for some of you folks in this classroom, even some of your friends who are not in this classroom, who you might meet in the hallway, see in the hallway, hey, they might not be the person who's going to really, you know, ace that calc exam or the differential equations exam, right? Or linear algebra. But that person might be very creative, really good with their hands, you know. So there is a place for them. So we'll talk about some of that. So that's what the thrust here today is. So I hope I know this point, you guys, that if you guys want to learn about something called 6-axis robot quaternion coordinate systems, there is a place for you there too. But that's probably not the thrust of today's meeting. So my background here a little bit, like Avanish mentioned, I have a few years in the industry working in various application engineering, project engineering type roles, but I would say probably that's the first half of my career. Second half has been more in the sales, business development, market development, things of that nature, more customer front end as we call it, right? That's where you're always talking to customers and working with them to solve their problems, because that's what engineers are trained to do. Also, I mean, basically, from an education standpoint, I came through the traditional route, going to a 4-year school, and then eventually taking more of a business education at MSOE with my master's in engineering management, and my undergraduate from the University of Buffalo, which is now a Division I school. Was not when I graduated. And then at UWM, they had a very interesting program when I was with ABB on developing leaders and whatnot. So it's really cool things. I think I've had a chance to have dabblings in different areas, and some of the companies that Avanish mentioned, these companies are, I would call them stalwarts in the industry, very much like GE Healthcare, you know, and what they do, right? So basically, when we talk about engineering type of companies, you know, we think about, you know, ABB, Siemens, Eaton, Rockwell. So that's the world, but these are companies. Sometimes the processes are really, really involved, right? So anyway, that's kind of the area I came from. Right now, what do I do today? So I've I've had a lot of, in 30 years, as we say in our corporate world, have done soup to nuts. You know, everything from working on the floor in a, you know, in a manufacturing or in a systems automation environment to corner office, as we call it. I've came to a kind of a, I guess, introspection with myself and say, what do I want to do now for the next several years? You know, how do I want to make an impact? So that's how I landed up in this role after ABB. Basically, I want to be just working with customers to help solve problems and hopefully have an impact. So what do I do there? I actually work on dissecting the requirements that customers send us. Okay, we look at their specifications, we take them apart, we look at what are the technical requirements, what are the commercial requirements, are there legal issues, are there issues with you know, some of the language in the request. We develop concepts and solutions. We apply robotic technology. Okay, that's why it's called applications engineering, not robotics engineering. That's a little bit of a different twist. We do cost estimating. We try to come up with costs of how the system is built, and we develop proposals around that, and we present it to the customer. And then sometimes we even have to do some preliminary project management. So what I'll do here is a little bit, kind of break it up into three major areas. One is, the first one is basically, we're going to talk a little bit about, you know, in the industry. Can I give you a little overview? I'm probably going to take you out of the presentation. We're going to visit a website or two to show you what that's about. So let me just take a quick poll. How many of you know what industrial automation or industrial robotics is? How many of you have done some research on that? Do you have a feel for what it is? Or, no, I mean, from your first experience, right? From robotics, you're designing and building your robots, right? Cutting metal, putting screws on, right? And putting motors on, programming software, and having the robots perform a specific task to a specific requirement, right? That's what we do every day. So if that's what you love to do, come on down, all right? But to do that, you're going to have to get some qualifications under your belt, and we'll show you that. So basically, we'll tell you a little bit about some of the, you know, how the industry is structured. Talk a little bit about some of the applications that I come across in my world. So I apologize that I'm going to be a little myopic in what I tell you about, because there's so much more to robotics, and I'll touch a little bit on that, because what I tell you is probably maybe 1/50th of what robotics is. And then we'll try to talk a little bit about some avenues of how you guys, you know, can plan your academic career. Especially, let's see, let me just take a quick show of hands. How many seniors in here? Okay, how many juniors? How many sophomores? Oh wow, all right. So I really need to have an effect on these guys.
We got a freshman too.
Sorry?
How many freshmen?
Oh, we got freshmen too?
Double.
Oh my gosh, fantastic. Welcome, terrific. This is great. So all right, so let's get into it. So first thing. So there's probably on this list here, you don't have to, this is an eyesore, don't try to read it. But what I'm trying to tell you is that the robotics industry has probably been around, I would say, at least in terms of industrial robotics, okay, industrial automation, probably since the 60s. Basically, there's not a robot history class today, but I'll try to avoid that. But it's been around for a while. There were hydraulic robots before. These robots actually had oil pumped into their axes, or they had hydraulic cylinders, and they would leak all over the place. They were really powerful. They were used mainly for heavy lifting applications that human beings could not do. All right, so people like Caterpillar, John Deere, the metals industry, people like that. That's where this was born. So since then, here we are, 2022 now. It's from the, I would say, 50s, 60s to now, and we're talking almost what, I can't do arithmetic anymore, but about 60, 70 years or so. So many organizations have come up, all right? You know, something on the upwards of almost 50 or so organizations, and these are all global, all right? This isn't just the United States. But there's a couple of them that really stand out that I would encourage you guys and gals to go and explore, okay? And that's part of the reason why I wanted to kind of say that here. So one of the organizations that we latch onto in my industry, because this is where standards are developed, this is where people go to when they need to understand what are some of the design practices that need to be followed. How do you learn about robotics? It's called A3. Used to be called RIA, Robotics Industries Association. But as of, I would say, a couple of years ago, they've changed over to something called A3. And it's actually more like A4 now. The part of the reason why it's A3 is because it's robotics, vision, motion control, and now AI. So it's more like A4. Another organization that I would highly encourage you to look at here is IEEE Robotics. IEEE stands for Institute of Electrical Electronics Engineers. Basically, they have a really good technical, a little more deeper technical approach to robotics. And then you have IFR, International Federation of Robotics. They're the ones who kind of maintain all the statistics of where robots are being used, what countries are making more robots, where are the applications being used, is it electronics, is it assembly, is it gluing? So let's explore that a little bit. I'll promise you not to bore you with too much website exploration here. Oh, takes a second here for this to get going, I guess. Let's see. I need to do something here. Get that going. What did I do wrong? Any wizards here? Let's see. All right, so I guess that's not working. That's okay. We can look at it afterwards. So basically, what you'll see in that, oh, here we go. Contact me server. That's nice. Can you see that now? I guess not. All right. No worries. So let's just go on. So basically, the way the industry is structured, in the world that I come from, I work for something called a systems integrator. Sorry for my marketing here, but basically I just got this today, so I was kind of excited to wear it today. The way this works is that, it's interesting. There's a process. There are organizations that are involved at every step of the way. All right. So I'm giving an example here. FANUC isn't the only one, but there are product and OEM suppliers. These are the OEM means original equipment manufacturers. Okay, they're the ones who manufacture an original piece of equipment, and some of that equipment could be a machine. Some of that equipment could be a robot. Some of that equipment could be a conveyor or PLCs. Has everybody heard of PLCs here? Programming, Raspberry Pi. So basically, these PLCs are what's used to control the systems, okay, that are used in robotic applications. So you have these folks who make these products, okay. Those products then are brought to people called system integrators, okay, and those system integrators are the people who do all the engineering to design, build, assemble, test, integrate, okay? So when you guys are building your first, robotic cells and whatnot, or robotic products, I guess, equipment, basically you're doing the same thing. This is what we do every day. So you're just doing it at a different scale. And basically that involves, once you're all done, you have software, you load the software, and then you start it up and you make it do its task, right? Sometimes we use, not sometimes, but a lot, we do have people called distributors. That's another part of the supply chain. Won't get into that here today, but there are other factors or other contributors. I've simplified this immensely, but there are many others who actually contribute to this equation. But basically, this is the general process. Then, so what, right? This is the so what factor. So you got people who make OEM products. You have people who bring it all together. Where does it go? It goes to people who make, I'm just using an example here. That's a John Deere tractor. Okay, so basically, we're talking about, you know, all the manufacturing processes, production processes, warehousing type of automation or processes there as well, plant functions, order management. Then we call it goods to customer type of management. So basically, when you take this whole enchilada, bring it together, that's the way the industrial automation industry kind of works, you know, in unison with the way things come to you and me. So when you order something from Amazon, okay, there are robots that are actually helping to deliver some of that. You order something from Walmart, Target. So that's when it's called goods to customer, okay? But before that, there's a whole lot going on, you know, probably months and months, weeks ahead of time, you know, to get to that system. So that's the general industry structure. So let me talk a little bit about some of the types of robots that we would encounter. Have you guys seen some of these kind of robots in different pictures, right? So basically these are Cartesian. You guys have all had math classes, right? So I think you're gonna know this, right? Cartesian robots, basically X, Y, and Z. Sometimes you have a rotational axis, okay? So Scara robots are more like the coordinate system they use there is more of a polar type of a coordinate system, okay? So they're programmed those, but that basically has, there's an axis here, there's another axis over here, and then an axis at the wrist, and this is called a quill. That goes up and down, and it's used for high-speed pick-and-place applications. Cartesian robots are usually used more so for a dedicated task, maybe a measurement or an assembly process. You put your device in there and it does its very specific task, and then that's it. Not always the the most articulated, or I should say most flexible, but it's used for dedicated tasks. These can go as big as the size of this room. Okay, I'm just showing you some example here. Articulated robots are probably the ones that you will see most frequently, and those are the ones that are most prevalent in the industrial automation space. All right, and basically these are 6-axis robot arms, and the reason why they're 6-axis, basically you have an axis over here, which is more like your waist. Okay, so it moves the robot this way. Then you have axis number 2, or they call it J2 over here. So that's more like, you know, you're moving your hip up and down. Then you have J3 over here. Okay, that's more like your shoulder. And then there's another axis, you can't see it, but it rotates this way. Okay. And then there's also a wrist axis, right? That's axis number 5. Then there's also a spindle axis as well, and that's number 6. Now, the coordinate systems that are used for this is not your typical X, Y, Z or a polar, you know, R, theta type of application, okay? There's some very heavy-duty math that goes on in here to make sure that the motions are all very coordinated. So, this is not a math class by any means, but I just want you to know, what is coordinated motion, okay? And this is what makes people like ourselves in the world that I work for, you know, this is what we do every day, is to how you optimize and make the best path for the robot to follow. So the difference between a non-coordinated motion and a coordinated motion is basically, if I were to take this glass of water, or a bottle of water, move it forward and move it to the right and down, that's a motion, yes, but it's not coordinated. Basically what I'm trying to tell the robot to do is, okay, I want you to go from here to here and find the most optimal path to do so, and make sure you don't hit something along the way. Okay, so basically that coordinated motion, it's going to utilize all the axes, it's going to know where it is in space, and it's going to take you there with the fastest and the most accurate path, as well as probably the most safest path as well. So how do you do that? There's different ways to program it. You utilize sensor technology, vision technology, okay, that gets integrated with it. So that's a 6-axis robot arm. Delta robot, we used to call them spider robots, because when you look at it, it looks like a spider leg with upside down spider legs, okay? And these Delta robots operate very fast. They're used for high speed type of packing and picking applications. Typically food. You will see these robots used in like loading up candy or and chocolate bars and little snack foods and things like that into boxes at really high clips. And basically the other one is called collaborative robots. That's more recent. And when I say recent, I'm going to say maybe a 7-year recent, 7 to 8 years. Why is it called collaborative? Because robots, this is where I don't mean to rain on your parade, but robots will kill you, okay, if you don't know how to use them safely. And that has happened in our industry, all right? So that's why there are standards written about safety. And that's why when I pointed you to that organization called RIA or A3, there's standards that are written usually with the collaboration of various industry experts from the automotive industries, from the electronics industry, and from other pharmaceutical industries and whatnot. So what we do there is we follow something called the ANSI, RIA, American National Standards Institute, and the Robotics Industry Association standards. Those standards are a culmination of things from OSHA, you know, Occupational Safety Hazard Association, I believe that's what it's called. And OSHA standards are all about safety, okay? And then also NFPA, National Fire Protection Association. So it's a whole bunch of different organizations into one. Point is, so what? What does that have to do with collaborative robots? Well, these robots are designed to operate collaboratively around human beings, okay? So if I set up a collaborative robot over here on this table, you can operate with it without too much worry about being killed by it. You might get clocked by it, okay? You might feel a nudge, but you probably won't get killed by it. Why? Because they have special force sensors, okay? And they also are, usually what you do is when you set up a collaborative robot, you have something called the scanner or a light curtain. And typically when you enter that zone, it goes into a collaborative speed. So pros and cons. Collaborative robots are great for facilitating a safer environment, but they can slow down your productivity as well, because now you have human interaction. Okay, but sometimes you want that because you need that. All right. One robot that I haven't shown here, which I was trying to find a really good picture of, but I apologize I didn't. Are mobile robots. I don't know if you guys know what, it was funny, when I was in college we had a project called the Mouse Project. And we actually designed an electronic mouse to go through a maze. That's what basically these robots are, these AMRs, they're called AMRs. Basically autonomous mobile robots, okay? Have you heard of AGVs, autonomous guided vehicles in plants, right? Well, some people say, oh, that's just an AGV. No, it's not. An AGV is different. And basically, an autonomous mobile robot is something that is going to find the optimal way to get from point A to point B in a plant. Okay? An AGV typically has a very programmed path. A lot of times they use magnetic strips. Sometimes they use different QR codes and things of that nature, or barcodes, or some kind of, I would say, a label or something for it to follow, or some electrical means. Whereas an AMR, way I would describe it, you guys have used, what is it, the taxi service, Uber. Yeah. Sorry, see, you can see how dated I am. My goodness, Uber. All right. So Uber basically is probably the way I would describe, or it's a parallel to an AMR. All right. Whereas if you go take the bus at the Milwaukee bus here to go home or to go to another part of Milwaukee here, all right, that's more like an AGV. All right. That's the difference. It's basically going to take the bus is going to go the same circuit route time after time after time. An AMR is going to actually find the best way to get there, all right, once you tell it where to go. So just an FYI, if I can find a video later, I'll try to do that. So anyway, so where are some of these things, where are these robotic systems applied? What type of industries? basically electronics, semiconductor. Why are robotics applied there? Main reason is because you need a clean environment, okay? These electronic fab shops, all right, they typically have, there's different measures of how clean you have to have your environment in that area. And it's measured based on the number of particulates of dust in a cubic space of that location, of that lab, okay, or that fab shop. So typically these robots are designed with special sealants, so that way it doesn't have something called outgress of those types of contaminants into that environment. And there's a rating for how those robots are rated for the electronics and semiconductor industry. It's class 1, class 10, class 100. That basically is the measure of the number of particulates in a cubic space. So that's electronics. There's the medical life sciences, also a very clean environment, but here you require safety and precision. Okay, that's one thing that, and cleanliness, all right? So that's one of the things that we also get involved with in that space as well, where you need a very high level of precision to execute some of the functions. Automotive, metals, machine tool, plastics. These are the traditional areas of robotics, very dirty environments where human beings, just didn't, basically it's unsafe for them. It's the parts are really heavy. It's also hard to find people to do those kind of jobs now. That's the other interesting thing, is that it's not just about, in the olden days of robotics, which was really probably not the best way to do it, but it was about replacing human labor, unfortunately, okay? That's not the case anymore, all right? Right now, it's more so about, we can't find the human labor, nobody wants to do those jobs anymore, so let's try to see if we can have robots do it, all right? So that's really what's going on in that space. And when I talk about these applications, some of the things that you see here that I've noted, that's more so probably in that middle bullet there, like automatic screw driving, automated gluing, soldering, injection mold applications, packaging and loading, material handling, so testing. So then you get into something called this packaging, is where there's 3 different types of packaging. There's primary packaging, secondary, and tertiary. And robotics is employed in all 3. And basically in primary packaging is really where you're taking the robot and utilizing it from a primary process development, type of a function. For example, you manufacture cheese up in northern Wisconsin, lots of cheese manufacturers. Basically, robots can be utilized in those types of applications, in those primary applications, because you actually have to touch the food. That's why it's called primary. You're dealing with that food. Then once you touch the food, you got to put that food into a container or into a secondary application. The secondary part of packaging in robotics, okay, involves basically taking the product, all right, that's already in a package, okay, and actually performing a function with that, all right, whether it's a automated packing application or taking it from a already sealed type of a, typically what happens in the primary, the robot takes it, puts it into a machine which seals it, so then you take the secondary applications where you take the sealed product, and the tertiary is now you're going to put that into a box, and that box is going to get palletized and sent to your favorite store, Pick and Save, okay? So that's really what that's about, and that's where robotics are employed quite a bit now. Warehouse and distribution centers. That is right now probably the hottest area, where robotics are being deployed. And your Amazons, this is your Targets, or this is your Walmarts of the world, all right? These are the people who are utilizing robotics in all forms, all right? All those types of 6-axis arms, mobile robots that look like your Roomba vacuum cleaner, okay? That's really where you see it. So let me see if this link's going to work now here. Let's see, I don't know. No. what we'll probably have to do to show you some of these links later is maybe just come out of the presentation and then go directly into the links. So let's go through this presentation and then I'll show you some of these links after. Those are kind of cool. So what are some of the key elements of a robotics and automation factory? What is it just a robot? No, it's not. Okay. One thing especially if you're going to be going into the field of engineering or the applied sciences and whatnot, there's a lot behind the scenes that makes an automation factory run. Okay, so robotics, as you can see, is just one aspect of it. What about all the other stuff? You got to remember, when you're putting together an automation system, you got to power it, right? You got to have power for your laptop. You got to have power to run your building here. In the same fashion, you have to have a proper amount of power to be able to deliver, into your factory. And it's not just any kind of power. That power has got to be clean. It's got to be consistent. It's got to be backed up. All right. Otherwise, we're not going to have milk, right, tomorrow. So these types of things are really critical. So I meant for a milk factory. So that's one area. And then the other area is process automation. This is where you're actually, manufacturing the product itself. All right. And this is where we, because the reason why we're talking about this is that sometimes we think of automation as just robotics, and it's not. And we're not going to be going into a lot of the details of process automation in this presentation today, but I want to leave you guys with at least the thought that there's more to automation than just robots. All right. At the same time, robots are an extremely critical part of it. But we have motion control as well, where we utilize motors and drives. Those motors have to be powered. Those motors have certain level of precision and accuracy to actually perform a function. They have to be up. They have to have high uptime. They have to be working all the time. They have to be controllable. You got to be able to go faster, slower, right? You also have to be able to what? Save energy. So that's a big one today in terms of what the type of motors that are utilized today in robots and conveyors. It's extremely critical the type of energy savings that you get out of it. Sustainability, that's a really key buzzword that you guys are going to hear someday if you go to, study engineering or something. You're going to hear a lot about, that's going to be part of your design criteria. So anyway, just a little touch on that there's more to it than automation. Now here's a typical factory layout. If you guys have heard of CAD, computer-aided design, this is done on a two-dimensional AutoCAD style software, but basically this is a whole battery of robots, okay, that are tending a injection mold press. So it's a big factory of presses that we designed. There's actually 5 presses, a forming press and 2 hot forming presses as well. So, well, they're not forming presses, but they basically actually put the, how should I say, the characteristics of the strength properties in container. If you ever gone to this application, by the way, if you ever gone to like Qdoba or a fast food place where they give you your food when you go home, those things are made in these mold machines, okay? And it's interesting because now these formulations that are being used in the process today are being made with molded fiber, which basically decomposes in 90 days. So why am I telling you this? Because when I was working on this project, we're robot folks, right? I'm a robot geek. I'm like, why do I care about that formulation? Why? Because it's all part of the whole equation. It's the whole enchilada today, right? So when you're working with customers and clients, they don't want you to just be myopic and have your tunnel vision. They want you to think about the fact that, hey, you know what? You're part of the bigger piece of the equation here. So that's what I was trying to touch on here. But basically what we have here is a full factory. So we talk about, once again, there's power being delivered. There's a power station outside, all right? And that power comes in. And then basically what we have here is, let's see, where does this all start? Raw materials, right? Raw materials are coming in. And you have tools and part storage. These are all the different tools that are used in the injection mold machine and on the robot as well. So you have that, and you have the actual press tending systems, conveyors or AMRs, like we talked about AMRs, right? Mobile robots. And then we have basically, these are all they call it ASRS. ASRS is another form of automation. It's called Automated Storage and Retrieval Systems. So this is where you can utilize robots to actually go and store and retrieve different products from bins and totes and shelves. Once again, I'm going to try to show you a video of that here afterwards. Packaging lines, shipping when it goes out, and inspection, of course. So just to give you a little flavor, this project itself, in terms of the overall size, probably nothing short of probably $100 million project, I would say. Okay, this is the magnitude of these types of programs that are going on in our country today, which is really cool. You know, it's not cool because it's a lot of money. It's because it's actually going to provide a sustainable future, and we're also going to be able to provide higher productivity of you know, for our people and jobs and whatnot. So it's all good. So this is another application here we were doing for a packaging company. Once again, this is a different view. What I'm trying to show you here is that this is a different CAD package. This is actually not, this is a three-dimensional CAD design. And basically, we utilize 3D a lot when we're concepting our work, okay? And this looks like a cartoon, but it's actually in scale. You're actually designing this while you're concepting it. So all these things actually have physical dimensions, okay? And basically what we have here is a packaging line. This is for frozen yogurts. All right, so the yogurts are actually coming off of a filling machine. Then basically they go into a cold storage area here. That's what I was talking about, the ASRS. That's a buffering type of a system. And there's a robot in there too, by the way. And then you also have, once it comes out of the cold storage, basically you have a packing type of robots here, which are those Delta Spider robots I showed you. And then this is a palletizing cell where you're actually packing into these boxes, and the robot palletizes that so it comes to you in pick and safe. So, but just to show you that this is based on a software package that's provided by a company called ABB. It's called Robot Studio. So, you know, we use different tools. There's SolidWorks. Have you guys heard of SolidWorks? You know, we use that as well. Here's just another view of it. So basically, once again, products arrive, all right, and basically they get buffered until ready for the multi-pack. So when you guys have your, you know, flavored yogurts that you bring to school, that's what we're talking about here, right? So basically these machines basically sort it out and put it into the right bin, and then this robot here is called unitizing. It takes that entire unit of yogurt containers and puts it into a box. So, all right, so now, if I wish I had shown you the videos because that would have been a little more exciting, but we'll get there. How do you get to this? That's what you guys are here for today, right? How are we doing on time? Oh, 7:39. Okay, good. So, basically, what is the path to get there? All right. Sorry about the. I don't know if you can read that, but so what we're looking at here is, you know, at the high school level. So right from freshman year, senior year, basically you're acquiring all your general knowledge, right? Your math, your sciences, and whatnot. That's all great. Keep it up. What I'm trying to tell you here, you know, in this is that sometimes don't think that, oh gosh, you know, I didn't take AP Calc 3, so I'm not going to be able to do robotics. Okay, no, that's not the case at all. You can still do all that, you know, at some point in your academic career. Just know that there is a place for you, and there's a different path here, and this is what I'm going to try to get to here. So basically, a lot of the colleges and universities, okay, the paths there, you know, you have the MATCs. If you go to like Slinger High School, they've got a whole robot lab. One of the things, I don't know if, let's see, Robert's not here, right?
No, Mrs. Leesky is here, one of our educators.
Oh, terrific. Hi, how are you? So basically on the launch program, we're looking at actually, you know, helping the folks at launch to try to see if we can put together a robotics and automation lab. All right. Basically, the idea is to get you folks skilled up, and ready for these types of jobs, all right, as well as for this type of a foundation for the next level of education. So what can you do? How do you get there? Do you go to the MITs and the Georgia Techs and the Worcester Polytechnics and the UW-Madisons? Yes, you can. Yes, you absolutely can. But that's not the only way. All right. So and then if you want to go, if you want to get started, there's a couple of areas I'm going to show you here in a second. But 4 years to grad school. So if you want to get into R&D, research and development, where you want to develop that next great algorithm of that robot model and make it faster, better, lighter, there is a path towards that. And that you would probably need to take it to the full hilt, okay, in robotics, where you go from 4-year to graduate school. But if you want a job in robotics, all right, there are a lot of different things you can do in the robotics and automation field. So I talked a little bit about some of the things that I do as an application engineer, right? R&D, we talked about that, but know full well that you can go into sales, you can do business development, you can go into applications, project management, finance and marketing. Why is that important? You folks are like, what? This guy's talking about finance here and marketing? This is gearheads, right? No, you know what? You need them all. You need everybody to actually get this type of stuff done in the real world. All right? You guys can invent the most whiz-bang robot out there, but if you can't market it, guess what? It's going to fizzle out. So basically, you need these functions, right? Or maybe you've got a whiz-bang robot, you've got a fantastic marketing plan, it's going to crush it, but you don't know how to manage your money and your resources in your company. That's why you need the finance folks, okay? That's what they're going to help you do. Some areas that, and we're going to try to get a link going here on this in a second, I'll show you. Space robotics. That's one area that I think that's going to be developing as the space programs start taking off. I think a lot of the R&D is still, there's a lot more work left to be done there, because everything that we've done so far for robotics has been terrestrial. All right, except I think in Canada we had the robot arm that was in the space shuttle, but that was the last time I'd seen something like that. So other areas, manufacturing, obviously some of the things we talked about, machine vision and AI. Let me talk about that. Don't really have a whole lot to show you on it here, but sortation systems, okay, when you look at, for example, packages, you got envelopes coming into, they're called package induction sortation systems at the United States Postal Service, UPS, FedEx, okay, all these folks I have to have that, Xbox here by tomorrow. How does that happen? Okay, basically these induction sortation systems are the way these things work. They have cameras, they're called stereo cameras. These stereo cameras have 2 lenses. They're actually able to make 3D calculations of where the robot is in space, okay? And that information gets basically transmitted to the robot coordinate system and the robot's control system, and that's how the robot can actually use those stereo eyes, if you will, to, just like how we do, all right, to basically perceive depth, okay, and distance. So similarly, yeah, that's how they run a lot of calculations on that. But where's the AI part come in? The AI part comes in because they actually take millions and millions of pieces of data, of images, okay? And as they capture those images, that brain, they call it, captures that information, and that is the information that's constantly learned through the machine learning algorithms, which is basically translated to the robot. So the robot gets smarter and smarter at how to find that package. I mean, you think about it, right? I mean, I know how to go after this mouse, right? I immediately picked it up at the right spot at the right time, and I'm going to put it down really nice. The robot's not going to know how to do that. It's literally a dumb mechanism, okay? But you start putting the AI and machine learning in there, okay, it will be able to mimic what I'm doing. And that's what's happening today, all right? So anyway, that's a little bit about that. Service robotics, we're going to talk a little bit about that. If you go to a hotel, okay, you might start seeing robots running around and basically disinfecting, or coming upstairs, hey, I forgot my toothbrush back home. Can you have somebody from the lobby send me a toothbrush? Here comes your mobile robot. It's going to be knocking on your door, and you know, and you'll know when it's there, because it's going to send you a signal on your cell phone saying, hey, I'm here. Here's your toothbrush. So that's coming. That's service robotics. The other is service robotics. We have kiosks. You want coffee. You want to have a sandwich made. You want gourmet pasta. This is happening today. I have a friend of mine who actually started a company not too long ago, and that's exactly what he's doing. He's making cookies, basically. If you go down to a shop, they actually have a full booth where you can get a custom-made cookie. That's his demo. But the idea is that you can utilize these robots for making something very specific that's repeatable over and over. Okay, and then what's interesting about that model is that he doesn't sell it for the robot. He sells it for the information that he gains out of it. And that information that he finds out what the customers like, he takes that algorithm or that information, and they develop new recipes to actually entice the customer. So it has nothing to do with the robot itself, you know, but the robot just facilitates that automation. So anyway, hospitality, security, yes, security, jail cells. Okay, you know, they utilize some of these mobile robots to go and disinfect jail cells, to actually go around keeping an eye on things, or empty stores after hours, having a robot, just kind of a mobile robot going around the store just checking on things. So these are all various types of applications. Let's see here. Oh yeah. So I talked, you know, I'm almost up to my hour here. You know, leave some questions, time for questions. But you know, for those, not everybody is geared. I'm going to say for a 4-year school. Okay. And it's also getting very expensive. So how do you get around that? All right. There's a couple different avenues. One avenue, I mean, you just Google it. Literally, right here in Wisconsin, we have 1, 2, 3, 4, 5, 6, 7, 8 programs that will get you right into automation in 2 years. Okay, you will have jobs that will probably pay you at a minimum of $65,000 to $70,000 a year. All right, and I'm not saying that's what you should do. I'm just saying, you know, if people think that the only way and path to robotics is going to, you know, to MIT or Harvard or Georgia Tech or University of Michigan, yes, you can, because you will get some interesting things to do if you go to those schools. But if you want to be in the industry, there are alternative means, and here's why I say this. I work with people from these types of places, okay? They're some of the smartest, most creative people, hardworking people I've ever worked with. And not only that, they didn't stop at the 2-year, all right? They started there, and they said, all right, you know what? I can't afford to go pay $60,000 to $80,000 a year for an education, but I can pay $8,000 to $10,000, maybe with a student loan or whatnot, or maybe with the help from mom and dad, and then go and get my 2-year degree. And then once I do that, I can actually maybe make some money, I can be productive, and possibly even have my company, who I work for, help me with my 4-year degree and finishing that out. And that 4-year degree is not going to take you a full 4 years. It's probably going to take you 2, maybe 3 at best. So, because you can transfer a lot of those credits. The only thing is you'll have to take the math, the calculus, and all that stuff. So, my point is that if you or your friends are looking for hesitant, there is a path for you. Please look these up. Madison Area Technical College, Gateway Technical College, Waukesha County, Black Hawk, Fox Valley, you know, and whatnot. I know these are probably not the schools on your docket. All right, I know the demographic that's here at Brookfield Central, but I can tell you that you know, there is an alternative. Okay, just keep that in mind. So some of the people who I work with, that's my boss. We have application sales engineers, electrical, mechanical engineers, so when you folks are looking at programs, whether it's 2-year or 4-year, you want to be looking at electrical, mechanical type of engineering as well, okay? So some of the other things in career paths, we already talked about, I think I've hit that home. Technicians are, a lot of times the people who have the 2-year programs are very happy being automation technicians. These are the people who go out there and implement the projects, okay? They might not be the ones who sit and design that sell as the engineer, but they're the ones who actually go out and make it work. And we always joke around in my industries that they're the ones who actually go and fix what the engineers messed up. So, anyway, so that's that. Job duties. What do you do? I mean, design, development of components, machinery, equipment. When I say machinery, I'm talking about grippers. You guys in robotics, right? You make grippers for your robots, right? Mm-hmm. So stuff. There's all sorts of different gripping type of methodologies. So there's actually a hierarchy. A gripper is just one aspect. They're actually called end effectors, okay? And end effectors can be a gripper, it can be a suction cup, okay? It could be any kind of device to actually handle products. So anyway, now I'm getting dweeby about it. But design controls, power distribution, like we talked about power delivery, right? And basically building and assembling these things, putting them all together. After you design it, you got to build it, right? So this is the kind of stuff that we do every day. Let's not forget some of the softer sciences here. Teamwork, right? Collaboration, mentoring, basically continuous education. You always, in my line of work, we have to stay on top of things, which means that I got to know what Uber means, okay? But my point is that you really do need to keep reading the periodicals, read the journals, see what's out there, see what's the next thing. Why? Because let's not forget we live in a society where companies compete for business. Okay, we still live in that environment, and to do that and to have a competitive type of offering, you have to stay on top of your game in that space, and also to be relevant as well. Oh my goodness, questions. Wow, we're already up to questions, and we got 7 minutes to go. Sorry. So yeah, while I'm getting some websites uploaded here, questions, folks? Nothing? Let's see if I can entice you with a few videos here. Let's see. So this is a company where I work, and just to give you an idea as to what we're talking about here. Let's see, there's a video? Yes, there is. Let's take a look. Lower the volume here a little bit so I can talk over it. Oop. So this is a very complex end effector, as you can see, all right? And you can see what the way it's, I mean, look at the level of complexity. This is a big vacuum system here, and it's also, I believe, that's a vacuum chamber. So that's a FANUC robot. It's a 4-axis machine, and it's not a 6-axis, but it's based on a 6-axis design. So this is basically called layer picking, okay, where you're picking up an entire layer of boxes, and that is a really tricky application. So why is it tricky? Because sometimes your boxes are not always of great quality, so you could drop one, or it might have, sometimes what happens is the flaps come off. There's all sorts of issues that happen in the field, but so that's a good example of that. All right, let me find something else here for you. So we also, I talked a little bit about, question, yeah. Cool.
So, I'm personally interested in biomedical engineering, and I was wondering how the concepts discussed today, like machine learning, are having an impact on medicine.
Oh man, you hit the nail on the button. I would say that what's happening is that when we look at machine learning algorithms and AI utilized in what you're talking about, with bioengineering and robotics, what happens is that when you're designing a process, whether it's a surgical process, or incision process, or a suturing process, or whatnot, okay, the AI algorithms that are used is, because now you have different types of, let's just say it's suturing, all right, for example, right? You have different geometries, you have different angles, different skin tones of people, different, I mean, it's incredible what you have to, research, in trying to make that right. It's not that simple. Those applications, I would say, are still out there and very challenging, and those are the kind of things that, I think would be great for you to look more into. But the bioengineering side of it, in my opinion, I think it still needs more development, more R&D. It's not as mature. So I don't know if that answers your question, but there's not a lot that's been done out there, to be honest with you. I'll tell you where it has. Let me pull this up. Basically, if we, let's see if I can find it here. Bear with me a second. How are we doing on time?
Yeah, we're good. And Siddharth had a question as well.
Oh, sorry. Where's he? Oh, there he is. Hey, he's.
What did you go to college for? Or like what was
Oh.
what was your undergrad?
My undergrad was mechanical engineering, and I minored in mathematics.
Alright.
Yeah. So, yeah, so to answer your question, service robotics, you talk about bioengineering, there is a lot being done. For example, it's in the service robotics space, where you can actually utilize, like, prosthetic, but electromechanically prosthetic assisted type of devices. Like for this person, the person probably can't walk, but with these devices, it facilitates a walking motion for them, as long as they can be upright. But you can see they're utilizing these types of canes to stay upright, right? So that's an area that's up and coming. Just to give you an idea as to where some of the installations, mostly material handling, welding, assembly, but so to your point, there's a lot more work to be done there. What else? Any other questions? No more? Trying to think here if I can bring up some more interest. There we go. So this is the A3. So I'll send this a PDF of this. So the links will be in there. So I would encourage you guys to take these presentations. Just go click on those links and explore. All right, just get deep into it. There's you can look at different solutions and products, beginner's guide, case studies, papers. There's all sorts of great information here. Okay. One other, you can go look at the MWES website where I work. So see what's interesting there. Which, by the way, we'll try to arrange for a tour. I'm going to say maybe right after the holidays, perhaps. Things will be a little slower. Or actually, things get slow in December. So I'll find out how we can arrange for a tour, for people to come out there. And you can see now hiring. So what else can I tell you? What else would you like to know? Is the other way to ask. I'm trying to think here.
Ask other questions you have.
Yeah.
About the technology, the industries, the careers. Maybe are the careers changing in terms of the kind of profile of the people you're looking for? Is it continuing to just evolve, or?
That's a great question, Deborah. I think that what's happening is that there is a inherent need for these higher skills. Okay, I mean the days of people going to work in a plant to go hammer an engine casting are gone. All right, so anybody wants a job like that, it's not happening here in the U.S. So long story short, to get jobs in manufacturing, something like that, yeah, this is a way to get into it, where you could still be involved in manufacturing of engine castings if you like that kind of stuff. So yeah, but it has evolved, to answer your question, yes.
Do you think that the automation of robotics will be applied in nearly every field one day?
Oh yeah, absolutely. That's why I'm trying to get to this one site here that I had up here for you guys. You're gonna love it, because I mean, as my cap for this tonight, I want to show you that if I can. I apologize that I might have lost my train here somewhere. Oh yeah, I got it. Let me It's the IEEE robotics site. I highly encourage you to look at that. Bear with me a second, because you're going to see that what I showed you is just the tip of the iceberg. Okay. So, if we look at yours, yeah, robots. So some of these things here you see, they actually have it arranged by, if you hop on the IEEE Robotics website, you're going to see what I'm talking about. Because right now, for some reason, I don't really have it well organized. But basically, what you want to do is when you go in there, so you'll see that there's robots from different, there's so many different, aspects to it. So take a look at space robotics, right? We talked about factory robotics. That's what I was talking about. So take a look. Disney World. If you like the entertainment industry, there's some pretty incredible things that you can see there, be involved with there as well. So yeah. Any other questions? So you guys interested in robotics? Still after today? I hope. Okay. Good.
It's definitely a lot broader. I think and it was interesting because the team also has visited some factories. Today they got to tour a site, and just being able to see the wide range of options and possibilities and realize that it's not shrinking. This is not an area of tech application that's shrinking. It's growing and expanding, and it feels like any industry of interest is going to involve some form of robotics and automation. So it just creates a lot of possibilities for you, all of you. I mean, no matter what industry you're interested in, robotics and automation is a part of it. And you, if you're interested in having those skills and applying them, you're going to find something in one of those areas that is a passion for you. So I think what's wonderful is Mr. Udani is both a BC parent, and he's invested his career in continuing to grow this really cool field, and he's kindly come and shared it with you and offered to take you on a tour, hopefully in the next month or so, so we'll get a chance to see some of that up close and personal. And there's nothing more exciting than a manufacturing facility with robotics and automation running, because you start to see possibilities.
We actually have a lab called, it's for additive manufacturing. It's called Adhere, that's the name of our brand, but it's called it's additive manufacturing is where they actually utilize, it's a very high-tech, advanced way of doing basically, what kind of printing? I see.
Like 3D printing?
Yeah, 3D printing, thermal printing, right?
Okay.
It's something like that, where we actually have a whole lab and a robot is being utilized in that process. It's pretty cool. And that's, so yeah, we hope maybe when you guys come out there, we can run that for you.
Oh, that'd be awesome.
Yeah, that'd be too cool.
All right, so you guys, any last questions before we wrap up? I know you guys have had a busy day. We had, like I said, we were touring since 3:30 this
Oh my
afternoon.
goodness, wow.
So they've had a great day, but so much learning, and we can't say thank you enough.
Oh.
The great news is that the kids are looking forward to also getting a chance to see all of that technology in action. as well.
Terrific. And I look forward to seeing everybody's resume in about 4 to 6 years.
Great. Okay, guys, say thank you, Mr. Udani.
Thank you.